Hello, I'd like to give a brief introduction to mass finishing processes. Mass finishing processes are typically utilized on metallic components that have undergone previous machining operations, though they can be used for non-metallics as well. Here are a list of processes that would fall into this category. They are similar in concept, but they have very different kinematics. Each process, the kinematics is quite different. The one we're looking at or most interested in is vibratory finishing, and I'll talk about that later. But first, why would you use these processes? Maybe just simply for cleaning. They're a great way for removing grease and dirt from components after machining. Where they earn their money is in deburring and creating isotropic surface finishes. So this is an example of a burr left over from a drilling process. These are highly undesirable in industry, and being able to remove them in automated processes is highly advantageous. This is an example of tool path marks left on the surface after a milling operation. These mass finishing processes allow you to remove these and replace them with an isotropic surface finish. And if your process is well tuned, you can actually get a high gloss finish on your component, which may be highly desirable for your application. They're also used to create favorable compressive stress profiles within the material, which is advantageous. Similar to what you would get in peening, though peening would probably give you greater degree of compressive stresses than these processes could achieve. How do they work? Well, I'll walk you through the process with respect to vibratory finishing. I have a very simple schematic here that'll help outline the basic kinematics and the basic components of the system. So we start off here. We have a container. Okay, this ranges in size from about 1/3 of a meter to over 1 meter in size, depending on your application. To the underside of the container, we have a motor which has an offset mass attached to it. The container is sitting on springs, reasonably stiff springs. Inside the container you have what's called media. Media is effectively what does all the work in the process. And actually the border of the slide here is an example of mixed media. They're stones or pellets that can be made from a range of materials, ceramics, polymers, metals, or even walnut shells are used. The size and shape that you use really depends on your application, but it's quite varied what is available out there. But nonetheless, no matter what you choose, you put your media into your container. You will also add in the workpieces that you wish to clean or deburr. Okay, so they go in there too. How the process works, the kinematics involved is you turn on the motor. When you turn on the motor, because you have this offset mass at the bottom, it sets up vibrations within the container. And these container induces the media to go into a steady state flow pattern, the steady state trajectory, similar to what's indicated by these flow paths here. And the workpieces become entrained within the media, and the relative motion between them is what actually removes material and gives you your isotropic surface finish. So it's quite a simple concept. To actually see a process in action, I have a video here. This is a setup we have in Charlotte. You can see here's our bowl. Here's the springs it's sitting on. Underside here is the motor. Which I didn't talk about before. This supply line will actually add compound to your media. Your media is in here. The compound is typically water and detergent, or water and degreaser, or you can add in rust inhibitors or some additional polishing compound as well. And you typically add in sufficient just to keep the media wet. You're not flooding the system completely, but you want your media to be wet. This frame that you see around here, this has nothing to do with the machine. This is where we attach the high-speed imaging camera so that we could capture the video, the other video shown on the YouTube channel. So if I turn it on here, we're going to zoom in. We're running this process dry. We also don't have any workpieces in here, but you at least get an understanding for the kinematics. Here's the media. You turn it on, and you can see it takes on this steady state flow trajectory. And when your workpieces are entrained within this, the relative motion between the media and the workpieces removes and deburr and clean your workpiece surfaces. You can run these processes anywhere from half an hour to overnight to get the finish that you want. So hopefully that'll give you some idea of how vibratory finishing works and the kinematics involved in the process. As said, this is a new research area for us at Charlotte, and over the coming months we'll be adding new video to give you a better idea of our research areas and topics. But if you have any questions, feel free to email. Contact details are here. Thanks.